So now today's lecture is about how to do deployment and integration of your applications when you deploy that on private cloud, public cloud, and the hybrid cloud. And of course, integration means how do you network your application together when they're running on single cloud, either based on Docker or VM, or if they're running on multiple clouds, say hybrid clouds. So although you think networking is handled by the TCP/IP stack and the other data center networking infrastructure, but that's not true. Networking, which works for your application infrastructure, is very complicated, that we will see today. And you need to know a lot of information about what kind of virtualization you're using. For example, if you're using a Docker environment, you need to know what networking features is offered by Docker, and then how you can use it to create your application architecture. Similarly, if you're using Amazon data center, you have to understand their networking and then build from there. So what I'm saying is, it's very challenging to create a really good application architecture, which is also clean from networking perspective, not just from a provisioning perspective that you're doing in your coursework, right? So in your coursework, are you doing any networking? Perhaps no, right? Everything running on one host. They connect to the bridge network, you assign ports, and it's very simple. But if you look into real application, they don't work like that, right? A real application will have multiple hosts. Perhaps each of them have different IP addresses, and you need a certain way for them to work together. So one, to work together at the level of TCP/IP, that is, each microservice can reach each other, and other at the level application, where you can segregate the application logic on as an overlay. So it's like two-level networking. You need to be aware to actually make your application infrastructure work. If it's based on virtual machine, is a bit simpler. If it's based on microservices, it's more complicated because we have more elements to network together, right? And obviously, if you deploy all your microservices, VMs on one cloud, it's a bit simpler as compared to deploying on multiple cloud from different providers. So as you see, as you get more production scale application architecture, things get more and more complicated, and you need to have good knowledge about networking, how to network application. So if you look at this picture, so you have an application that you need to deploy on multiple clouds, and what you need is an API. The API that will help you interact with the hypervisor of that cloud data center, or if that whole data center is managed by Docker, then some API to connect to Docker engine. Perhaps from the coursework, you got already hints on if it's Docker-based, how do you connect to it, right? You have the command line, you have Docker for Windows daemon, you have some Java library, so there are Python libraries, so there are some ways you know how to deal with that. However, if I ask you that you have to connect to Amazon EC2 cloud through their API, then maybe it's difficult for you because they don't support native Docker APIs per se. They write one layer on top of that. So for that to happen, either you have to go use Amazon SDK, or there's alternative, you can use JCloud that we will learn today. So JCloud will help you program both Amazon cloud as well as the Docker cloud at the same time, because they write a wrapper on top of both of them. Right, so this is just an context. If you get some other new cloud provider that doesn't support Docker or JCloud, then it's complicated. We need to implement that new API as well. So it gets complicated in terms of application networking integration. So the goal of today's lecture is to understand what are the challenges, and then from that challenges, whenever you face a problem, you can start thinking, how do I solve that problem? So that's the key here. Of course, here I cannot give you solution to all the networking problems that you will face in the future, but at least give you something to think in a methodological way. If there's a problem in networking, how will you go about solving it? Right, so today, in the last lecture, we finished the image selection, and now today's focus is deployment integration, and then on Monday we'll do monitoring and other operations. So let me go one by one, and today we are going to see a snapshot of what are the different level of networking required for your application, one at the level of actual infrastructure, and one actually at the level of microservice itself. There's like a two-level networking you need to do as part of your application. And what are the different ways available for that? We will reflect upon that today. So just going quickly back to our first lecture where I said about physically hosted application. I mean, in data center where it is not virtualized and you're using a flat tree topology, and without virtualization you want to network your applications together. So that was done in more of traditional way. There was one-to-one mapping from host to your application component, and you use the domain of the data center itself, and then use load balancer to distribute your load across different parts of your application, and then for fault tolerance used to replicate your storage to the other data center. This is what was done before cloud computing and before virtualization, when everything was one-to-one on physically hosted server. And we reflected quite a lot upon that. What's the problem of infrastructure which is not virtualized, because hard to scale, hard to manage, and one hardware can host only one kind of application. So to overcome that, we looked into virtual machines. So in case of virtual machine, the servers and application are broken into smaller VM allocation, and those VM are somehow consolidated on fixed set of physical servers. And then obviously, as compared to physically only server, in the virtual machine, you end up with many components, and then you need to come up with something called virtual networking. And that was something done through SDN, software-defined networking, and NFV. You can use those to network these multi-capacity virtual machines together. So as you see, as compared to fully physical infrastructure where you have one-to-one mapping, networking in virtual one is more complicated, because one physical host can have multiple virtual machine. So you just need, so you have one physical IP address and you have multiple virtual IP address. So you had a virtualized TCP IP card to change from physical address to virtual addresses. But you see, it takes, it won't be there. I just changed last minute, right? So you have one physical address there, and then you need to convert that to multiple virtual addresses, and that was done through by virtualizing the network TCP IP card that we reflected in the virtualization lecture, how multiple virtual machine can access the TCP IP stack of the host virtual machine. So this was in the age of hypervisor-based VM, and they had solutions around that, around virtual LANs and virtual TCP IP card. But the focus of today's lecture is what are the ways to network your application in context of Docker and microservices, which is, I think, is the current trend in industry, and we should be learning about that. Of course, some of your old code can still use VM-based networking, but they are trying to replace that with Docker-based networking because it's much simpler to use, and it has a lot of native support from Docker engine itself, so it is much more agile, and it's easy to implement in your network and more scalable. So before we go into the details of what are the different network drivers available in the Docker, we just take a quick overview of how you interact with the Docker. So how you interact with Docker is you have a command line that interacts with the Docker daemon running on your host, and through that command line you can send multiple commands to the Docker daemon, like docker build, docker pull, docker run, and based on that thing the daemon does certain actions. And how is daemon doing those actions? Because the interpreter for those commands is already implementing inside the daemon, and it's doing the building of images or pulling of images or running of images or mapping ports. It's all done automatically by the Docker daemon. So have you tried doing this thing through some code, some SDK, perhaps Python, PyDev for Docker? So then well, in that case, there is a SDK layer here that talks to Docker daemon, and then you can do everything to the code. Similarly, you can use JCloud and write. So to some extent, you did a bit of easy task in the in the coursework because everything was running on the same host, so it simplifies a lot of complexity of deploying distributed Docker application. But maybe perhaps that is something only possible in 2 weeks of coursework, so we can't complicate it further. Then he used something called Docker Compose to create Docker application stack. So pretty much a Docker application stack includes set of microservices that together solves certain problems, certain features. For example, you can have an application stack for a bookshop, for a student management system, for a cinema ticket booking system, for a hotel. It could be anything that all those microservices packed together as part of a single application stack, and you describe all the dependency around Docker Compose the YAML file, and then once you execute that, it creates your instances. Did you guys use Docker Swarm? Any of you? Docker Swarm? All of you? Right. So once you describe your dependencies in the Docker Swarm, for example, this one shows that you want to create 5 replicas of your web container. So based on and 1 replica of visualizer, it creates 6 instances of microservices across 2 Docker hosts. So this compose is based on the point that your Docker cluster already has 2 hosts, and will based on Docker Swarm scheduler, it will distribute your containers across those 2 hosts. However, now the question is, if these are on the same host, the networking is a bit simpler. But if these hosts are different on different physical machine, what are different mechanism available to network these containers together so that they can talk to each other, which is quite a baseline for any production application where components actually need to talk to each other. Okay, they just don't sit on one host and do some small prime number test that we are doing in the course. So they do much more than that. So these 2 are Docker host, and then these are your microservices. Right, so if you just go to Docker command line and do this Docker network ls command, it will show you different kind of network drivers available to you. So if you look at the bottom one, the none driver, as the name specifies, none means no network. So if you have a none network attached to container, that means nothing will happen. So why you think they would have given a none driver? Is it useful? If you guys know about IoT, Internet of Things, in that we use a none driver because we have some sensor which is just collecting data, it's not sending to anyone else, for example, and we collect data from there manually by putting a USB key. So they can work on none driver. So it's just not given for doing nothing. It is used in some scenario where a container which is hosted on the edge, sensor edge gateway, doesn't need to communicate with anyone else, just collecting some data about this building or something, and every week we just come, put a USB key, collect data. So for that, use the none driver. So basically, none network driver means it will not configure any IP for container and doesn't have any access to outside external network. Right, there's other way to create. So the other 2 networks are the Docker host network and the bridge network. So going one by one in that detail. So if you want to create a Docker host network, you have to run command docker run ---- net host. So what basically this Docker host network means, you use the same namespace, same TCP/IP stack of the host on which that container is running, and it will provide the same speed as the host TCP/IP stack. So, but what do you see is the problem with using the host networking stack for connecting your container to the outside world? What could be the challenges you will face in a production environment? Yeah.
You might have like different services running, like for example, on 488.
So conflicts. So port conflict is one of the major issue. So if you're going to run only one host, maybe it still be okay, perhaps. But if you have multiple containers running, multiple services, and they need to communicate on different ports, they might conflict, and it's not really suitable for production environment. It is suitable more for your scenario where you're trying to learn how Docker works, but not really for production environment. There's other, I know you all used Docker Swarm, but you could also have used Docker Bridge networking as well. So what happens whenever you create a Docker image instance, the instance of that Docker is automatically connected to the internal bridge network driver of the Docker daemon, and all the Docker container connected to that bridge can talk to each other. But what do you see the problem with that? Problem with that, because the bridge belongs to one host, those containers can only talk to each other. For example, say if you look at this one, so this one shows that the subnet is 172.17, and you have 16 bits for the host. So you can have 2^16 number of hosts. So, but all those hosts need to be on the same host to be able to talk to the bridge network. So the problem with bridge and host network is that you can use that for communication between the containers which are running on the same host. However, if a container running on this host want to talk to a container running on this host, it's not possible through the bridge network. Right? Another problems. So that's the first problem, and as compared to the host network, if you want your bridge network containers to talk to outside world, you can use the port mapping feature to connect to the host port. For example, you can use this -p command to map the port 80 of the host machine to the port 80 of the container machine. So this one is better than the host one because you can have differentiated port mapping feature. However, our challenge is how can we make the containers running on different subnets, different domains, perhaps different data center to talk to each other. Anyone has any solution for that? Because that's the real application deployment scenario. Different containers running on different data center, different subnet domain, different IP domain, maybe someone IPv4, someone IPv6, and you have somehow got to find a way to network integrate your containers together based on your coursework knowledge.
Can create a virtual network.
Virtual network, yeah, something like that, yeah. Swarm, distributed swarm, the swarm that goes across multiple data center. Easy to say. Last year I had one MS student doing the project, took him 3 months to configure that between Amazon and his laptop. I don't know which way it goes because of the Amazon's own networking stack as well, but at least easy to say it will take you 1 week to configure between your host across different data center because of different stack. So yeah, that's the solution. Or you can use your own overlay, but then you have to implement your own routing features, your own security features. So, but to help you with that, Docker offers the overlay networking. So, are you guys using overlay networking driver for your coursework? Right. Okay. Then you already aware about how it works on a single host, at least for that matter. So, to help you with simplifying the networking of containers running on single host or multiple hosts, Docker daemon provides, or Docker engine kernel provides something called overlay networking driver. So in pretty much, if your Docker containers are part of the swarm overlay and they register to that overlay, then they will be able to communicate with each other just by using the overlay virtual IP addresses. They don't need to be aware about the physical addresses on the host. And all this conversion and virtual routing to physical routing switching is done automatically by Docker Swarm kernel or Docker Swarm daemon. It is done automatically by them. So someone who finished his task of the coursework early, you can try to integrate your computer container to the Amazon container using this driver. That might fetch you extra marks if you can save, you can do it. I mean, that will need time, but if you have time, I will recommend you should try it because you will just learn more. It's all about learning more features, right? So you should do that. So for example, so in this one, you have 24 bits allocated for the network prefix and 8 bits allocated for your host prefix. That means on this kind of overlay, you can have 255 hosts. So this, I'm thinking you know how IP addresses and binary arithmetic works for IP. So here we can have maximum 0 to 255 address for the host. So you can have 255 hosts. So that's based on binary calculation. That's how the computer works in the power of 2. Of course, if you make this as 16, then you can have 2 raised to 16 hosts. So based on how many hosts you want on your overlay network, you will decide how much prefix you want for the subnet and how much you want for the host. Depends on that, and 2 raised to that will decide what will be. So in here we can have almost 2 raised to 24 subnet. That is like more than 50,000 overlay network. You will never need that. So mostly should use 1616. Then you will have a good balance of the how many overlay network you have on per overlay network, how many hosts you can have. So then, how to create an overlay network? Of course, you can directly invoke the overlay network through the command, or more nicer way is to use the Docker service command, because it automatically creates the overlay network driver for you. So if you use this command, it will create the 2 replicas of the web container and map the ports, as well as will create the overlay driver for you. So inside the Docker daemon, VXLAN kernel is the actual code that creates this overlay driver for you. And the VXLAN is actually an overlay on top of the actual factory network of the data center. So if you understand VPN, that virtual private network, so you can relate the VPN to VXLAN driver. So it is an overlay over the underlay. So your data center has an underlay of networking infrastructure, which will be based on, say, factory topology that we covered in lecture 1. And then this VXLAN creates an overlay on top of that. That helps you create an overlay of containers inside the smart overlay networking. So we have got Zenu here to think about how this all links to SDN. So the next time when he teaches SDN, he should be able to link this overlay networking to SDN. So if once you create the overlay network, the hosts on different machines can easily talk to each other just using the overlay addresses. Right, so for example, if the container on the first host has an address of 10.003, I want to send a message to 10.004, it just needs to create a TCP IP packet, send here, a message will be delivered to that host using the VXLAN driver. However, my question is how this is implemented in reality. Can that container just jump in messages to this host? Because as I said, this is a virtual IP address, doesn't exist on the physical router. So how this could happen? So how this is resolved? Any idea? I want to send a packet from 10.003, which is on the top host to the host running on the bottom host on 10.004. Do you have any idea how this could happen? Will be resolved by the VXLAN driver? Yeah.
So the packet created by the 1728.18.03 is the payload in the packet created by 10.001 that goes to 10.003.
Right.
And it extracts the payload and sends the payload as a packet to the other one.
So you see here, that's true. So this container has 2 IP addresses.
It's just tunneling, isn't it?
It's just tunneling. So it just goes out as 103, that goes to 10.01, and then from here, then the payload is taken out. So all this thing is done by the VXLAN driver. So once you create an overlay, this is good for your understanding, but all this will be automatically done by the overlay driver, so you don't need to worry about it. But of course, when you need to worry about it, when you need to debug your application, if something goes wrong with the network, when something is not arriving to the point where it's supposed to arrive. But all this tunneling and payloading is done automatically by the VXLAN driver for you, so you don't have to really worry. And Docker Swarm overlay networking, if you use, you can inter-network your host on the same data center, also different data center, but just because they are not binded by which subnet, subdomain you have, as long as you configure your network driver correctly. So if in the exam, if I ask you, if you want to deploy your application on multiple clouds, what will be your answer? So one answer could be this: I can implement Swarm overlay networking. But other answer could be also that I can use JCloud. So, right? So you have to think how much marks this question is for and answer it in a way. And of course, if you describe overlay networking, you describe why. It will give the reasons of VXLAN and the tunneling, all those things. If you use JCloud, there's different reasoning for that. That we'll look into now. But one feature to see, this is a low-level networking, right? This is, if you look at the Swarm overlay, it's a low-level networking, which is a bit far from application engineering, your microservices. So if you want to handle this on top of your application, for that you have to do this one, as well as you have to deal with this vendor-specific API. Do you get what I mean, or it's more confusing? So say you have two data centers, right? Both are managed by Docker engine. However, if you take Amazon, if that Docker engine is behind a hypervisor, then you need some API to access those hypervisor first. So how do you access those hypervisor? You do through this vendor-specific API. So then you have two levels of integration to do. One, after you enter the hypervisor, how do you network your containers together? But before you entering, you need one more API. So it becomes a multi-level integration problem. So it's good to understand that when you program a Docker-based application or even non-Docker-based application. If everyone is running Docker, then there's no problem, right? We just use Docker networking and it will work fine. But normally, even if people use container service, they don't expose that. The run is behind a hypervisor for security, as we see in virtualization lecture. So then you first need certain way to enter the hypervisor, which will be only possible via the vendor-specific API or using the global API like JCloud that we'll talk now. And then once you're inside, then you can use your Docker networking or whatever. So it leads to multi-level networking feature that should be part of your application code. That's why implementing hybrid cloud becomes so complicated, because once you have to take care of low-level networking and then as well as the high-level application networking. So we'll look into more detail. So for example, for now, let's keep aside Docker and go back to say 2014 when Docker was not there. That time, Amazon has a data center, Microsoft has a data center, Google had a data center, RightScale had a data center. Each one has its own SDK to program the application. So if you want to deploy an application on Amazon, you had Amazon AWS SDK. If you want to deploy application on Microsoft, we had Microsoft SDK. And if you want your virtual machines to run on Amazon and Azure both, you have to implement both the SDK. That was the state of the art before 2014. To solve that problem, open source team has come up with a solution called JCloud. So what JCloud does, they go study the SDK for each of the individual cloud providers and they abstract the SDK as part of one global SDK called JCloud. So if you use JCloud, the same code could be used to deploy a virtual machine on Amazon, on the Azure, as well as on the Google or any other provider. And as of now, they support more than 100 providers. So you can use JCloud, write one code that can help you deploy application on more than 100 cloud providers, so that you don't have to care about the vendor-specific API. In a way, it's very nice because then your application architecture is not linked to one single provider. You can use the same code base to interact with multiple providers.